No, I do plan on having them done before I go to bed. I stayed up late last night. Well, late for an old guy like me. I stayed up 12:15. I know for you guys, the night's just getting started. 4 hours left, but when you get in your 30s, especially now my upper 30s, that means the next couple of days you're gonna get rough with that limited sleep. So that's what I'm saying. For you guys, I'm at 12 o'clock looking over like, oh, I still got time. So typically I'm a 7-hour minimum to 8-hour sleep a night type of guy. So. But you are right. I did say by today they'd be done, and they will be, or by yesterday. So the projects are graded. They're just not in Skyward, but they're on Canvas graded. And I was checking through your guys' free response questions. And Lucas is emailing me how he's slacked off into new stuff. So I'm having to fix his grid, go backwards, fix something he didn't turn in. And talk about our day 2 regression analysis stuff here. So what we're doing is looking at, okay, alternative methods or other methods of finding our least squares regression line equation. Some more interesting facts about regression and how it works. So we're going to do some experiments with different data sets and see, does this really affect my R value? What should I be concerned with? And then if we have time, we'll get to outliers and influential points. We'll see how things are going. Okay, so we got some more time next class to catch up if we need to. So on your AP formula chart, they used to give you this big mass of chaos, and they've decided, you know what, now that we get to do things with a calculator and we're comfortable with doing that, you know, they finally joined the 21st century. They eliminated those formulas. So yeah, the really hard looking crazy ones that you'd have to do by hand, gone. You don't need them anymore. So if you're looking on your screen, a couple of these formulas, or at least one of these formulas should look familiar. All right, so they're gonna remind you of what your equation is on your AP formula chart, and I'll be getting you guys one of those to keep here at some point. We just don't need it that much yet. And plus you guys already have your notes, but there is, especially when we start getting later in the year, we start having all these crazy formulas for probability. So that's when y'all start handing out the formula charts. And we're going to talk about these two here in just a moment. So these are alternative methods in helping us find the least squared regression line and our correlation value. So here's what all those little letters mean, in case you want to jot these down here in your notes, because you do get the formulas, but they don't always tell you what every little symbol and letter means. Most of these hopefully are familiar now because we've been practicing these enough. But you'll see things like A is still your y-intercept. B is still your slope. Where's my mouse? There it is. My chat window disappeared on me. Oh, that's not good. What else? X bar, average of X. The little s with the X underneath it is standard deviation of X. Same thing for Y, average of Y, standard deviation of Y. And correlation coefficient is our R value. All right, so while you guys are writing that down, I got to hunt down my chat window. It disappeared on me. Where you go, chat window? That. It's the full screen. Where you at? There it is. Good. Technology is only so fun when it works. Keep my participants window open because people's internets at home drop out and they want to get back in. Some of them. Okay, so let's talk about these new formulas right here. Sorry. Everybody in class is like, Mr. G. So 6 hours of sleep, 2 nights straight. So disclaimer, stuff may look weird. Go with it. It's Thursday. I knew Matthew was going to come in here and bust all over me if I didn't get his grade done, and I still didn't, and I didn't get to sleep, so it's all lost for me. So when you guys come in on Monday, I'll just quit. You have a new teacher. Standards will drastically improve. Because nothing says, you know, better quality teacher than hiring somebody who hasn't been hired yet in the middle of the year. That always cracks me up. Although there has been some cases where it can only get better. I had that situation a few years ago. Not with stats, but with a different subject. They're like, we fired that teacher, my good. You can put a plant in there, it's gonna improve. So she was trying to run one of the PSAT tests, and I was one of the hall monitors. And I've never seen 2 principals have so much like white ghost panic in their face, because apparently she was way off script, and it was for a class full of juniors where it counts. And they're like, could you please just read? I was like, I got it, just get out of my way. she was on the wrong page, reading the wrong instructions, and the kids were filling out something they weren't supposed to fill out, and it was going to void all of their tests. And that's where you get determined if you have the National Merit Scholar level. Yeah. And so they were just like, can you fix this? I'm like, yep. So I told them, I was like, erase everything. We're going to start over. And we still got done before everybody else. We'll get it. I felt bad for them too, because they're like, we don't know what we're supposed to be doing. She was off on page like 96. I'm like, yeah, you start on 3 where it says start here. I don't know how it was that difficult, but she's teaching chemistry. So nothing will ever go wrong in that class. So 50s, early 60s, somewhere in there. But it was, the sad thing was she was half AP, half on level chemistry. And I'm like, if you don't read the instructions properly, that's not the class you should have like somebody just trying to figure it out on the fly, because those things are a little volatile. So, yeah. Anyways, okay. Sorry, I get off on tangents when I'm waiting. You can manipulate using algebra this equation here. In fact, we're going to do that. So if you want to jot that down in your notes, you don't have to do algebra over it all the time. Because when we're trying to find this equation here, our y hat equals a plus bx, we need to know the a. So instead of sitting here all the time trying to figure out what a equals, we can just change it. So if you want to kind of add an extra formula in there for your help, basically you're just subtracting a from both sides, subtracting y average from both sides, and then multiply everything by -1 to get everything back to being positive, then you're all set. That's why this switches to a negative symbol. If you're like, why'd they go negative? Just because we wanted to reverse this. We wanted a to be positive as much as possible. So, that should cover everything. All right. So let's practice using those equations. So the following statistics are found for the variables posted speed limit and the average number of accidents. All right. So this is an intersection, street, whatever. And we're not given a list of data like before. Instead, we're now given the average for X, the average for Y, the standard deviation for X, the standard deviation Y, and the correlation coefficient. So we want to find the equation and predict the number of accidents for the posted speed limit of 50 miles per hour. So if we look at our formulas that we have on our notes, the first thing we can do, we want to get to this equation eventually. We want to get the y hat equals a plus bx, right? That's the format we want. So we can figure out a and b using the formulas in our notes that we had. So if I look, the other equation I told you guys to write down or convert was the a is now equal to the average of y minus b times the average of x. But there's a problem here. We still don't have b yet, right? So we're going to go ahead and jump into the other equation, which is b is equal to the standard r times the standard deviation of y over the standard deviation of x. And be careful, it is y on top and x on the bottom. So it's reversed here. So this is the equation you're going to start with, because we know these two things and we know that. So our b is going to be equal to our R value of 0.9981, and it's a very convenient problem that everything we need is just right there in front of us. Wish life was always that way. And then standard deviation of y is 8.4, and standard deviation of x is 11.6. Again, disclaimer, red alert, hint, hint, whatever you want to call it. Okay, watch your x's and y's on this. All the time I see students flip these. It just happens. Like they get in a hurry or they look at the numbers in a glance and then they would flip this around. So make sure you're being careful. All right, so we're going to do this in the calculator. 0.9981 parentheses are our friend, 8.4 divided by 11.6. So need a class auditor to make sure I'm not going crazy, and volunteer, tell me what they got for their answer for B. That's what I got. Everybody else get the same thing? All right, so 2 people agree with it. I'm not going too crazy yet. So B is equal to 0.7228. We're rounding to 2 decimals. Very good, Matthew, for remembering. So now we can take our B value and we can come over here to this guy and plug him in here. We know our Y average, correct? So we got 18. We know our B now is 0.7228. And we're going to multiply that by our X average, which was 40. So now everything's starting to come together. 40, not a 46. There we go. So again, one more time in the calculator, 18 minus my 0.7228 times 40. All right. Let's see. Who should I pick on? Lucas, I'll pick on you. What'd you give me? Did you get it? For, yes, A. Okay. I got 0.912. Either answer is correct. So Lucas, don't change your answer because that's actually the one that's in the slide. So you're actually more accurate than we are. because we rounded already. And if you don't round, you get a better answer. So you're good. Yeah, so perfect. So you're actually more accurate than we are, but both answers are correct. Okay, welcome to statistics where you can be off by a little bit and still be good. All right, so everybody's got the right answer. We're doing this right. So I'm gonna clear my drawings now that I know my A is equal to, and I'm gonna write the one I got, but the one Lucas got is also correct, 10.912. Again, because we rounded, we were being bad. So I now have my A and I now have my B. Can I go ahead and make my equation? Perfect, so you guys know what to do from here. So let me close that off, press the mouse button, and there's your equation. So remember, it's y hat, because we're still predicting, is 0.7228x minus, and then Miss Nichols just flipped it because negative numbers on the front of her equation bother her. So if you like the negative number 10 in front still to match the format, that's fine. Minus 10.9105, again, that's the answer Lucas got because he was smart and didn't round. We rounded, so we get negative 10.912. Either way, you're gonna be okay. So don't stress. And this is not pre-cal class, and we're not making measurements of vectors, so we can be okay. So what do we do as our last step? How do I predict the number of accidents with a 50-mile-an-hour speed limit? Plug her in, right? So we take the 50, pop it in right here. So when you do that, that's what I get. See if you get the same thing. And it might be, again, a few decimals different because we got a different formula or a different decimal entry theme. Does that make sense, Derek? Right. Okay, you're looking at me like I messed up, and that's okay if I did. Call me out on it. Good question. So you would report this as your actual answer. And then if it was one of those, and we'll talk more about this, especially when we start writing up our reports in the spring. So what you would do then is not erase this or fail to put it. You would draw a little arrow and you would say, it means 25 accidents. And you write the word accidents after it. So this would go right there. So good question, Matthew. You're thinking ahead. So we want to make sure we report both though. Okay, so if you are rounding to the nearest whole number, because yes, obviously 0.2295 an accident, whatever that stands for, we don't care about. We want an actual number. But you would draw a little arrow saying that, like, I knew this is my real answer, but I know this is also a better answer. And that way, you'll get full credit that way on your AP exam. I didn't mean to erase all that. You'll get a full credit on your AP exam that way because they'll know you knew how to calculate it correctly and you know what it should be rounded to. So, yes, excellent question there. If you look for decimal right now, I'm not going to take off points on anything because that is the answer. Like, that's your Y hat answer. So, yes. I know it's weird because we've been trained. I know I had for several years of math class. It's like if that, like cans of paint. Okay, if I need to buy 25.22 cans of paint, I'm rounding up because I'm not going to go to Home Depot for 0.2 of a whatever the thing. So I get what you're thinking, and you're perfectly smart for doing so. So right now, just write the actual decimal answer. If you feel better writing the second one, just draw a little arrow and say I'm rounding it to this. If that makes because I don't want you to get off of that idea either because we will get back to that in the spring. Now, here's the other thing to consider if we're doing an analysis later on this data. All right, this could be good news or bad news depending on who I am. So if I'm like the city engineers or whoever design or determines the speed limit, the safety commission, whatever their name is, and I'm like, oh, okay, good. We used to have 100 accidents on the street at a higher speed, so this is perfect. 25 accidents, while not ideal, is definitely better than 100. So we're good at 50. If I'm a person who's working for the insurance company or I'm an automobile driver owner, all right, any accident sucks. So anything over 0 would make me unhappy. And so we could, as statisticians, if this is something I'm saying as you guys get older decide to do, it's not always going to be your job to say, here's good news or bad news. A lot of times you just kind of go, here's my report. Here's what happens. Now you make the decision. I'll take my paycheck, in this format and have a nice day. Like I did the numbers for you. You take the information as you want. And so you can translate to them what this means, but you're not there to make the decision, which is kind of neat when it comes to statistics stuff. If this is, again, a subject that interests you. If it doesn't, then I'm just let that happen right there. All right, we good with this? Easy enough. Alternative way number 1 to find our equation. I like this a little bit better. To me, a lot less work. I don't like sitting there all the data points. All right, let's look at the next thing then. What if we get a computer-generated output like this? So I'll go ahead and I've ran all sorts of data on the knee surgeries and the age and the range of motion of patients. And so for these 12 patients, I put it all into my fancy computer program and out spits this report. And this is a very common report you'll see in a lot of statistics analysis. And so from this computer generated report, we want to be able to pull off the important numbers in order to make our equation. So the first thing you want to notice here, where your constant and your coefficient kind of meet up, this is going to be your y-intercept. So it's a constant number that's always going to be in your equation. So in this case, this is your letter A, your 107.58. The other nice thing about these reports is they're consistent. So it'll always be located in this spot. All right, if I give Matthew another one, it's not going to be suddenly like over here. And then I give, Lauren another one and it's like right here. Like it's always going to be in the same spot, which is nice. That's the consistent thing about these things. The other coefficient, the other thing that stays consistent in your equation is this number down here, and that's your x variable and your slope. So it tells you right here what your input was. So this is your explanatory variable. Boom, that's nice. Thanks for telling me that, computer. I appreciate you. So we know that as we input age into our equation, it's spitting out range of motion as our response variable. So it tells you the name of your x variable, so you can go back up here into the problem and make a note of it. And it tells you what the b value is. So you got a value, b value, what your x variable is, and now you know what your y variable is too, because there's only two of them. So if age is your x, then the other one, range of motion, has to be your y. All right, questions on that so far? And we're going to practice doing these in like homework and stuff as well, so you'll get more practice with them. All right, in order to make our analysis fully done, though, we still need to figure out our R value. So we have our equation now. We would say y hat is equal to 107.58 plus 0.8710x. So we got our equation. We're okay with that. But we need to make sure we define what our x and y variables are. So in this case, age tells us is our x variable, and our range of motion will be our y variable. So make sure as you're writing these equations, you guys are defining your x and y in terms of words. That was one of our things we learned last class. You got to be descriptive. You got to be specific. There you go. That's what I was thinking of. All right. So just from this tiny little section of my data output, I'm able to figure out what my equation is and what x and y stand for. It's nice. And data punching is not required. All right, there's some other useful things on here to look for. Some that we're going to use this unit and some that's going to wait for us until we get to the spring. So something else to look for on here is the R value. So what they give you instead is R squared. Well, could I find R from R squared? I mean, what's my solution there? Just take square root, right? Just like we can find standard deviation from variance. We just take the square root. And so in order to do that, you're going to want to make sure that you convert it to a decimal first. Okay, so don't just get all excited like, oh, 30.6 square root. Make sure you convert it to a decimal. So you should get 0.306, then square root that. We will never, ever use in this class, and very rarely ever use the R squared adjusted. Please be very careful with that number. It comes with the reports all the time because it has its purpose, but nothing that we're ever concerned with. And so when you get this report, just put a line through R squared adjusted, A, D, G, J there. And don't let it fool you, because if you try to take the square root of that one, you're going to get the wrong answer. All right, it always comes with the report, but it's not going to help us. We want just good old R squared, take the square root. R squared is an important measurement too, but we're not going to talk about it today. We'll talk about it on Monday. All right, so we have our R value now, 0.5532 after we take our square root. So now we can go ahead and with this information say we have a, what's kind of strength? Moderate. Now, if I take the square root of a number, can I tell the sign of it? No, right? Because it could have been two negative numbers or it could have been two positive numbers. I have no way of knowing. So how do we determine then if this is positive or negative? We go back and we look at our slope. So what was our slope here? It's positive. So they're going to go in the same direction. You're not going to have a positive slope with a negative relationship. That wouldn't work. So you have to watch the place value, I guess, of that one. That's not really the right word, but you have to watch the sign in front of your slope. If it's negative, then your R is supposed to be negative. If it's positive, then your R is supposed to be positive. So in this case, we had a positive slope. We're going to have a positive R. All right, so all these little things that we've done in math before, it's like stats. They pull little things from here and there. They don't really do one thing overall. All right, what else we got? Watch out. Yeah, there you go. Watch out. R can be positive or negative. The sign is determined by the slope. All right, so we've learned how to read and make these equations from data points. We did that all last class and this afternoon. We know how to do it from our averages and standard deviations using the formulas. And now we know how to do it from the computer readout. Any questions on this before we play with our regression a little bit and see what happens? Matthew? Al, ask away, man. The only way to tell for sure is to graph it and look at it. Obviously on this would be difficult because we don't have sets of points. So you would have to go in there and maybe pick at least 5 points at random and test it out and see what you get. Because you could put in different values of X. If you know it's age, just think reasonably like age would be. So, 20, 27, 35, 70 something, somewhere in that range. And then you'll know, that'll help you out, but you have to graph it. There's not going to be any numerical indication necessarily that you have a linear relationship or not. Some people will say that the R sometimes tells you, and that's true. And we're actually going to experiment with that in a second, but it doesn't always tell you. So like if you see an R that's at 0 or close to it, that's probably an indication that you might have something nonlinear as well, but not always the case. Sometimes you get an R value of 0.99 something and it's still not linear. Yes. Right now, we're still assuming it's linear as of today because we won't learn nonlinear until next Wednesday. So yeah, on all homework up till this point, you can still say linear on everything just because we haven't, unless you got a graph right in front of you speaking at you like that. And we're going to see one here in just a minute. Then, yeah, that's a good question. Never be afraid to ask the questions, man. I want you guys to know if you leave here without asking the question, then what's my point of being here? Okay, so last thing real quick, you'll see standard deviations. This is what we call the t-scores. We haven't even gotten to that yet. And this is our p-values. So like I know what these mean, and this tells me things. But as far as you guys, we're not even concerned with this yet. So right now you can put a big hex through it. We're going to get to these in the spring. So we'll let spring come around before we stress about it because who knows between now and spring what we'll be doing anyways. So right now there's no point in stressing it. They're important, just not what we need right now. Okay, let's play with some regression data and see what happens with our life here. So we're going to type in these numbers into our lists. So go to stat, go to edit, clear all your lists out. You want to not delete them, but make sure you have fresh lists because we're going to use 6 of them here in a second. If you want to do shortcuts. If you don't want to do shortcuts, you can do it however you're doing it. But if you want me to show you some shortcuts and how to use your calculator, clear your list of everything. And let's play with some of these dots here and see what happens. And if you're looking on your notes going, where is all this at, Mr. G? Don't worry, we'll get there. All right, I messed up last class, so make sure I'm correct here. All right. Get your data, get your data. I would personally be happy if by the spring I don't have to wear this mask. That would be, just start with that. Everything else can stay like it is. People that want to stay home can still stay home. I don't care, but darn it, I want to get rid of this thing. Tired of smelling my own breath. You have garlic pizza and you're like, okay. So what we're going to do is we're going to see, number one, if we convert our numbers, say that my data is temperature or my data is in feet and I want to go to miles or anything like this. Say I want to convert my data. Is it going to affect my R value? Am I allowed to do something like that, or am I going to get a completely different correlation between my data and mess up my analysis? So what we're going to do is transform this data using these equations. So you can do it the hard way. You can go through each X value, plug it in and find your new answer. Or if you cleared all your list, I'll show you guys a shortcut if you don't know how to do this here in just a second. So we're going to convert our X's and our Y values using these equations. So let's do the X's first. We want to take all of the X values, add 14 to them, and multiply by 5. So 5 times X plus 14. So here's my data. Go over to list number 3. And start typing in your equation. 5, parentheses. Now, if you put in the letter X, it's not going to know what you're talking about. Of my 2 lists, which one is my X value? So we're going to hit the second button, and number 1. So it's going to tell the calculator, take my list 1 and add 14 to it and multiply it by 5. If you press enter, ta-da, you just saved yourself. I know, isn't that nice? Lauren, what'd you do? All right, I'll come look at it in just a second. All right, now we can do the second one. So we had take y, add 30, and divide by 4. So go over to here, take y, so in parentheses, what is my y values? L2, add 30, right? Did I say that right? And divide by 4. Ta-da! That's nice. All right, let me see what you did, Lauren. Lucas. Okay, you go to the very top. You got to be at the very top where it says L3 titles. All right, so go up to you got to go up to the top. Oh. Yes. This is going to take your whole list and make a new list. So go up there now. Type in 5. Not 5. It's 5 in front times L1 or second L1. Yeah, plus 14.
What's the y?
The y was y plus 30 divided by 4. Yeah, you got to work. You working?
I don't know what the equation is.
Oh, okay. I'll put the equations back up.
My app won't let me do it.
Yeah, some of those apps are cheap. All right, there's your equations. So for list number 1, add 14, multiply by 5. So this you just replace with L1. This you replace with L2. Nice. That's what I say. Clear your list because we're going to use 5 and 6 in a minute. Because it's very easy when we graph to just say, hey, look at these 2 lists. Or when we do our correlation, say, just look at these 2 lists. So this way you're not like typing. You got to go up to the top. So hit up one more. That's what's key. Yep. I see if Zoom people are having issues too. Can you show us how to do that again, L3 and L4? Wait, never mind. I got okay, yeah, no problem. So one more time. Has everybody got the equations in class? So one more time, if you're doing it, I will clear my lists here because this is the one I have memorized. Yes. So anytime you want to clear your list, you can go, it always starts here. You can always go up one more. Like they don't really tell you that, but you can do that. So if I want to clear the list, I can hit clear from here and I get a fresh list. Please don't hit delete or many tears will be shed because the whole list just disappears. And so you have to like either add the list back in, reset it. It just takes a little bit longer. So be very careful. You can experiment later, not right now. All right, so I go up to the very top. So if you're just sitting right here on this blank, it won't do anything. So you got to go up to the top and say, okay, do 5 times my x values, which in this case we said was L1 plus 14. Let me make sure I did that right. Okay, and then I press enter. All of my L1 lists get converted. It's very nice because on Wednesday next week, we're going to use it very heavily to convert our nonlinear data to linear data. And you don't want to have to sit there and do logarithms one at a time by hand. So we're practicing it now with less stress because when you have 20 to 25 data points, if you're trying to convert using logarithms, no thank you. Okay. Everybody in Zoom looks okay. So now what we want to do is do another regression. We want to do 2 regression analysis and see if our R values change. So first I'm going to compare the R value between L1 and L2. These are my original data sets. So remember how to do this. Go stat, calc, go over to number 8. And then say, yes, X is L1, Y is L2. We can kind of jump ahead on everything, hit calculate, and we care about this right here. This R value, so 0.9181. So I'm going to write it down in my notes so we don't forget it right there. Everybody see that? Everybody got that? Now, this is my original list of data. This is the old X and Y. This is not the converted one yet. So what we did for list 3 and 4 is we converted them, right? We changed the temperature. We made feet become miles, whatever. Okay, whatever conversion you're doing. Is that going to change my R value? So what we're going to do is look, we're going to hit stat, go back to calc, excuse me, hit number 8 again, or go down to number 8. Now this is where we get to be flexible. We can say, sorry, we want our X list now to be number 3. So hit second and then number 3. And I want my Y list to be number 4. So hit second, number 4. So now when it does an analysis of this data, it's going to do that. What do we notice? We're good. So don't worry about converting your numbers. So on your notes, We're going to see here in a second. Transformations are not going to cause it. So don't worry, I'll give you the words in a second, but that's the first thing we just tested. And we're going to test all of these, and then we're going to go back and summarize it up with words. So this is the part I'm getting ready to do. All right, so we just learned that you can transform your data, convert it, whatever, and you're going to be okay. Your points are going to stay relatively the same strength and relationship, and we completely randomized it. Like those were not the same transformations for both points, right? So like we did one equation for X and we did a completely different equation for Y. So it does not matter how you do it. It doesn't have to be done by the same equation. So you don't have to convert them both to feet or whatever. You can still keep 1 centimeters or whatever you want to do. All right, so that was the first step. Next step. Oh, that's the wrong thing. Told you, it's going to get crazy today. Next thing we're going to do. So here's your first sentence coming up. The value of R is not changed by any linear transformation. So the blank, which is value of R, is blank, not changed by any linear transformations, including unit changes. Which is nice, because sometimes we're going to want to convert this stuff. And we don't want to panic and be like, oh my goodness, I'm going to change my R value. You will not. Your equation might change, and that's okay. We don't care about that changing. But your R value will stay the same, so your relationship stays the same. All right, next up. We're going to switch X and Y, just for fun. What happens if I put my X's and my Y's and my Y's and my X's? So what you can do for this one is just when you get to your regression, flip it. So what I mean is you don't have to retype anything. You don't have to copy anything. You go to your calculate menu, you press number 8, and we say, nope, this time my X values are actually list 2, and this time my Y values are actually list 1. So we're just flipping it. So you go through it, calculate. What do we notice? Still the same. So you can have X's be Y's and Y's be X's and let them do flips around each other or whatever you want to do. You're not going to change your R value, which is good. Again, we want to be able to measure the relationship between our two variables. So this helps out. Okay, so I'm trying to show you guys shortcuts so you don't have to spend hours, minutes, seconds, days, whatever, typing in lists over and over again. It's tedious. It's not fun. And I don't want you to hate the class because of that. So use these shortcuts. All right, so slide number 2 is going to give you the answer for the next blank. The value of R did not change when we switched our variables there. All right, so coming up, it says, I'm probably going to come up here in the next sentence. The first one, oh my goodness, nothing but trouble. So your first blank is the value of R is the word in the middle, not changed by, and then do your thing. Expect that kind of stuff from Lucas, but not from you. Lucas is like, why am I getting picked on? Because he emailed me again about the work that I didn't unlock for him. Good. All right, for the next one, the value of R did not change or is not changed when you switch the X and Y variables. So the first blank should be value of R is, and then not changed, and then you're good to go. So the words up here are a little bit different, but this will be your first blank, value of R. Second blank, did not change, or is not changed, so, but not changed right now. It's not perfect. We've changed these notes a few times since we printed the paper. Apologies. All right. Let's look at a new list of data. So make this one, what's next? 5 and 6. So X values go in number 5, Y values go in number 6. Some of you guys who are really smart with math know what I'm doing here. Some of you guys. Others are looking at this as just random numbers. All right, so you go do your stat, go do your calc, number 8, change it so that the first one is 5, and the second one is 6, and let me know what you get. guys get that? What happened, Mr. G? Well, this is where we need to answer your question from earlier. We need to look at the graph and see what's up. So we're going to make sure our stat plot is on. See, mine is off because this has been reset. So turn it on. Make sure your lists are the correct ones. So 5 and 6. Much easier to do it this way than to retype everything all the time. And then hit graph. You might have to hit the zoom button in number 9. And what do we see? Ah, it's not linear. What happened? So that's kind of a hint that you have an issue. Kind of. Doesn't mean that it's going to be guaranteed to be quadratic. It just means that the linear relationship between these two data points is very poor. So R is only measuring the strength and direction of a linear relationship. If they happen to be quadratic, we might get something weird like we just did. So we're not going to know for sure until we graph it. Okay, so 0 doesn't mean that it is quadratic. So don't just, oh, it's 0, it's not linear. Look, if I had a bunch of random dots just all over the screen with no pattern whatsoever, then it's not quadratic either. It just means that you just don't have any relationship going on. So you would say no. In this particular case, it's not linear, but there is a relationship here. It just happens to be not what we're studying right now. So just be careful when you get your R. Don't get too excited and be like, oh, there's absolutely nothing there, and move on. There could be a relationship still. Maybe we just identify that in our problem, say, it's not linear, but it is quadratic, but because we're not dealing with that right now, we're moving on. Now, on Wednesday next week, we'll discuss how to fix this and make it linear. So if you've done logarithms before, that's how we'll fix this. And there's different formulas. And then now that you guys know how to do the shortcut in the calculator, the logarithms will take you all of 10 seconds. You'll type it in to the calculator, press enter, and all your numbers will get converted to the new number. You go back and regraph it, and we'll be able to see it. Otherwise, you'd have to do them all, like, and then and it's, nobody wants to do that. Anyway, so our last little points here. So the value of R measures the extent to which X and Y are, and this is underlined on purpose, linearly related. So this is bullet point number 3. So there is a relationship here. It just ain't what we care about right now. And there's nothing wrong with a quadratic equation. It's actually very useful. You guys have heard of exponential, growth and stuff in economics classes or whatever. So they're useful data points. We're just at this point in time only concerned with linear data. All right, questions over. You guys all look like it's Thursday and you're ready to go home. I'm with you. Zoom, we good? Questions? You got work, yeah, sorry. It's taken me a while, but I'm to the point where I look forward to the weekend. I used to not be that way. All right, last couple of facts. So some things to wrap it up. The correlation coefficient, this is not your bullet point yet. I'll tell you when we get there. The correlation coefficient is not affected by linear transformations. We saw that. So adding, subtracting, multiplying, dividing, all values in the data set by a constant will not cause my data to be completely messed up. So that's okay to do. Notice it does say by a constant. If Matthew decides to add 5 to this one, take away 15 from this one, multiply this one by 3, yes, he's going to completely screw his relationship up because now the points are going all over the place. But if he wants to consistently go through the whole set of data and change it all by the same constant, he's fine. Okay, if Lucas wants to do the same thing, he just wants to flip his X and Y's because he's like, I prefer this to be my explanatory variable and this to be my response variable, he's fine. You can do that. So don't get too concerned with it. The reason why we go over this is sometimes converting it makes it easier, all right? So we could go back to that age and baby's height question and say, putting in age sucks. I'd rather put in years. Okay, we can convert those numbers all over to years and we'd be okay. It's not going to change our relationship on that. All right, the correlation coefficient is a measure of our linear relationship between X and Y. X and Y could have a nonlinear relationship, but answering Matthew's very good question earlier, we're not going to know until we start graphing things. So if you don't have data points to graph, then you're going to have to be a little creative and decide, okay, here's my, age is what it's talking about, like the knee thing. I'm going to put in 5 random years in that area, at least 5, maybe 6 or 7 years that I think would be good years for somebody getting, knee surgery. So I'm not going to put in 1. Okay, I would hope that my little 1-year-old infant baby is not getting knee surgery. And I'm not going to put in like 400. Okay, we're not talking about Moses. So we want to make sure we keep it into, today's standards on stuff. So here's your next bullet point. the point x, y, or the average of x and y, is on every regression line. This could easily be proven using the formulas from our formula chart, and this is part of the minimizing process. And then your last bullet point there is at the bottom. Your equation and the correlation coefficient are both, here we go again, add more to the list, non-resistant, meaning outliers are going to kick them in the teeth. We got just enough time to finish up my last part and get us exactly where the other class goes. All right. Because you guys leave early, you won't have class time to work, so that's okay. I think you guys like leaving early. All right, so your last two bullet points, the point average of x, comma, average of y is on every regression line somewhere. This could easily be proven using the formulas from our chart. This is a part of the minimizing process. And your two things are non-resistant. So really, again, what do we have as resistant? There's only two things so far we talked about. Median, think of box plots. IQR, there you go. Those are the only two things that we've said for sure that outliers are not going to mess with. Everything else, I mean, it makes sense if you think about it. If I have an outlier, I'm going to change my formula. If I have an outlier, you know, my R is going to be different. We're going to see that here in just a second. If I have an outlier, then my mean changes. All that stuff we talked about. So there's only really two things that don't get concerned with outliers. I'm trying to think if there's another one that we talked about or not yet. All right, anybody still writing? We okay? All right. So let's real quick kind of discuss outliers versus influential points. So an outlier, and according to our bivariate scatter plot data, is an outlier as a point that's far, far away from the line, okay, relative to the other points. An influential point, on the other hand, may or may not be next to the line, but it definitely significantly impacts the slope of the line. So we're going to look at a little bit more data here in just a second for tennis rackets. So the last time you have to type in data today, I promise. And we're going to see how much does an influential point / an outlier mess with my equation, and why is it a good thing to get rid of them? Which may feel a little dishonest, but it's not. Who's trying to call me? Like, for some reason, my phone does not. I bet you I know what. From Allen High School, what? A110. Why would somebody in A110 at the high school want to call me? I don't know. Missed call. Allen High School, A1. What is A1? I leave it on do not disturb because I don't want phone calls. Is such and such in your class? Why? He's happy here. Leave him alone. Always looking for somebody. I was like, well, they come to my class because I don't bother them. Maybe that's why they're not in your class. All right. I'll put it back up here in a second if you still need it. I want to make sure we get the data in for the people that are doing okay here. So there's your data. Don't type in 1 through 14. That's just a label. So you want to put the resonance in here on the X values and your acceleration in the Y values. Last list we got to do today.
Clear everything else, right?
Yeah, you can clear the rest of the stuff back up. I know. This is like the worst part of the class. And don't do like I do and put 111 in as 11. It happens all the time to me. Last bit of data. We need to look at what an outlier does to our stuff. So. I can feel the love, man. Everybody's like, yeah. So the easiest way to fix it is to hit second mem or the plus button, 712. Just reset your calculator back up to normal. I know there's a way to put it back in there, but the steps for it are a lot more complicated. And just make sure you go back into your mode there, Derek, and turn your diagnostics back on and you're back to normal. That's the easiest way to do it. It's happened to me in a test before in college. I'm like, what? And try not to cuss with the professor sitting there. And then you're like, you know what? I'll just reset it. There is a way to do it though. I'd have to go back in there and play with it because it's been so long. I don't remember how to do it. So hit mode and it's like fourth from the bottom. So I've been there and done that. Like I say, it'll always happen to you when you need it the fastest. Yeah. I think I got everything right this time. Last time I screwed up because my limited sleep faculty. Boom. Yes, that's fine. All right, so put your stuff in there, and then what I'm going to show you guys is a neat little trick, so this is worth your time. I'm going to show you guys how your calculator will put the equation into your graph for you. So you can actually see the line in your data, and you can actually make predictions. I didn't show this to fifth periods. I didn't remember to do this. You can actually see the prediction, make the predictions fairly easily without having to retype the equation all the time. It's kind of neat. So when you hit enter on function, you'll find Y1 in there. Yeah, for some reason, she left that out on the thing. It depends. Yeah, so it depends on if you have, like I did the same thing earlier, you got to have your stat plot back to X1 or what? L1 and L2. Derek will be the only guy good to go because he's completely reset. So all the stuff we screwed up, he'll be like, heck, what are you guys talking about? The rest of us will be like, it's not working, I got errors. All right. Again, get your data in here. I'll leave it up here for just a few more seconds because I know it's getting close to 1 and you guys want to head out here pretty soon. So. All right, anybody still need it? I know poor Derek had to reset, so I'm trying to give him a minute. Now you know the pressure I have, except everybody gets to see me make those mistakes on camera. You're just sitting there by yourself. Poor fifth period's like, Mr. G, press this button. I'm like, oh yeah, sorry. Making zombie mode up here. You can have Matthew read them out to you, keep him awake over there. He's falling asleep. What time does it start, man? Our zero period is almost done by then. Zero period starts at 7:20, so our kiddos come running in right at 7:20. Like, I don't get anything anyway. That's the one class nobody shows up early for. All right, so you got your data in there, ready to go. This is what your list should look like if you reset everything. We hit stat, we go to calc, we go down to number 8, so everything's the same. Be careful, make sure this says 1 and 2. So we're good to go there. Now, don't hit enter on calculate yet. Go down to this neat little trick where it says store reg, and then you're going to hit the vars button. And then go over 1 to y vars. This is in your notes, so you don't have to worry about writing this down. And then you have to press enter on function to see all the y variables. So what this is going to do is it's going to take the equation it's about to make for you, the y hat equals a plus bx, and it's going to automatically type it into the y equals locations in your calculator where you can start graphing like actual lines like you used to do in Algebra 2 and pre-cal. So instead of you having to sit there and type it all in and make it pretty, it's going to do the whole thing for you, automatic, not rounded, perfect. Okay, so that's nice. We can do it at any of the y bars. We're going to use 2 of them here in a second. So we're going to do the first one in y1. All right, we're going to press enter, let it calculate everything. So real quick, just so that we can look back. So I had a weird R value in fifth period. My fifth period doesn't talk to me. I was messing up like crazy. And they're like, no, it looks good, Mr. G. I should take off points on their test. That'll teach them to pay attention. So point. All right, so that's what your R value should be. Is that what you guys got? I specifically asked them too. I was like, did you guys get the same R values? And they were like, I'm angry at them. All right, so there's our R value. So what we want to do here in a second is look at our graph and see, are any of our points weird? All right, we're looking for outliers or influential points because in reality, if I'm a salesman of these tennis rackets, I want to be able to say with certainty, hey, you know, the less resonance your tennis racket has, the faster the ball is going to hit. All right, do you want your ball speed to go faster on a tennis court? Or vice versa. Maybe you want to play on the clay courts or grass courts where they're notoriously slower. So you want to add more resonance to your racket. And I want to be able to sell the person the right kind of racket. So I want to make sure before I go and make, you know, tons of money off of people that I'm honest with them. I'm trying to be a good businessman. Or maybe I'm auditing somebody who makes a claim and I want to test if they're being true or not. So we got to go to our second Y equals stat plot. Before you hit graph, make sure those are back to L1, L2, because we had it on 5 and 6 last time. Otherwise, you're going to get what Lauren and I had earlier, and it's going to say error. All right, so go over to the graph. Everything will be all weird, so you need to hit zoom, and then number 9 to rescale everything. Boom, there's our data. So what do we see? Do we see a weird point on there we might be concerned about? Yeah, this ugly looking guy right here, right? So we want to remove him just to be safe, because he's not, like, there's all the tennis rackets, and then there's the Roger Federer special edition. Or whoever you like in tennis anymore. I don't even know who's still playing. So you want to get rid of this point. So we're going to go and hit trace real quick. I want to make sure I know what that point is. So I'm going to kind of move the right arrow over after I hit trace, and it's going to highlight all my dots. And it's going to say right there is 189 and 30. So the one that was giving Derek a hard time, we're going to get rid of it. He's giving a hard time for a reason. So we're going to go into stat, edit, and then take out the 189 and the 30. It should be the last one if I remember correctly. Yeah, there it is right there. So make sure you delete both of them. Because if you just delete one, you get an angry calculator. So it's gone. Points disappeared. Now, don't go too excited yet in graph. Be careful with these next couple of steps I want to show you. Has everybody got the point deleted? Just go over it and hit the delete button. Smack on the table a little bit. Erase the memory with a magnet. I don't know, something. No, it doesn't. All right, so now hit stat again. Go back over to calc. Go down to number 8. L1, L2 still good. When we go right here, we're not going to do Y1. We want to see how much that point changed our graph. So when we hit our vars button this time, and we go over to Y vars, and we hit our function, we're not going to hit enter on number 1. We're actually going to go down 1 because we don't want to overwrite our previous equation. We want to still leave it in there just for comparison purposes. So hit enter on Y2, and that's what it should look like this time. Now go to calculate. What's the first thing we notice before we even look at the graph? Our value went from strong almost to terrible. So does there really appear to be any relationship between resonance and ball speed at all? No. So I'd be lying to my customers. I'm like, yeah, you know, that lower resonance really increases your ball speed by like a good factor of like 2. I'd be BSing myself and them. So there's really nothing there. Very weak relationship. So now go back to graph. And be careful you don't hit zoom number 9. Just leave it in the screen it was already in, and you can see what happened to your equation. So that little point down there, it wasn't an outlier because it wasn't far away from the line. Like, it was within our equation. But what it was an influential point. Because this would be a significant change in my slope. Okay? And so this is what you kind of have to do to test when you're looking at your data. So let me wrap this up on our notes part here, and then if you guys have any questions, you can stay and ask, and then if you don't, then I'll let you guys go here in just a second. All right, so does there appear to be an influential point? Obviously. Yep, we found out because we put it into the calculator. We did it with Y number 2, and we saw that the slope drastically changed. So we removed it. Did that cause my slope to change? The answer is yes. Okay. So as far as the stuff there at the end of the notes, there's not really anything to write. It's just something to kind of keep in mind as you're going. We are going to stop here in just a second at the definition of lurking variable. We're going to talk about that next time. So if you look here, I'm going to try to make this fancy because I have, you know, super high-end CGI graphics. Original graph, new graph. Original graph, new graph. See, I'm going to go real fast here. Like, ooh, it's fun. So that's how much it changed. So next class, you guys will have a warm-up again. We're going to look at the minister data. Okay, so we're not going to put it on the screen. Matthew is correct. The grades were supposed to be done last night. They're about halfway done. They will be done today because I don't want to do any work this week. And Matthew's like, sure, whatever, Mr. G. He's probably right. No, I do want to get them done today. If you are failing, like the class as a whole, and you want it fixed for AM, then you're the person I'm looking for. If you're passing the class, but you just want the grade to be better later on, then don't panic. We still have time to go back and fix stuff. So you don't have to take a test or retake a test if you're still passing the class. You still have time next week and the week after to do it. So I know some of you guys are like, oh, I don't have time. I've got 6,000 things this week. Perfect. As long as you're passing class and you're not going to AM, we all have time. I just want to make sure you're not going to AM unless you choose to go in there, which is not a bad thing. It helps you get more study time. But I know as seniors, you value those privileged periods you work so hard for very preciously. So if you're passing my class, then don't stress. I will go through the emails and fix everything else. Danielle can't wait to get out of here, so have a good day. See you guys later. We'll see you on Monday. Have a good weekend. Don't work.
Mr. G.
Yeah.
So, like, what would be the point of taking out